Namaskar, my dear friends. So let us quickly see TSOP1 series IR receiver devices. So in this session, what we'll try to understand is what are the overviews of IR sensors, what is the schematic design, where it can be used, like it can be used in remote control systems, and what are the different features and block diagrams and everything. So we'll try to understand quickly with TSOP1 series, which is from Visa Technology. Okay. And the device that we are using for our application is TSOP13436. It can be used with other parts as well, like TSOP13438. Okay, the older parts were TSOP1836 and TSOP1838. So these were the parts that were in older time, right? So if you see some of the features, it is an individual IC setting to reach maximum performance. Okay. Then it is having immunity against noise, lamps, and like LCD TV and Wi-Fi. Okay. So if Wi-Fi, LCD TV and all are there, their noise will be immune. It has low supply current. It has photo detector and preamplifier in one package. The supply voltage is from 2 volt to 5.5 volts. It can be used with your 3.3 volt application as well as 5 volt application. Okay, these are the standard voltages for your circuit designs, right? Coming to the fact that applications, so it can be used in your infrared remote control systems and mechanical data. If you see, it has 3 pin. It looks like this. Okay, so this is the IR receiver sensor here mounted, and we have pin number 1 as output, pin number 2 as ground, and pin number 3 as VS, which is VCC kind of thing, which is power supply pin. Okay. If you see the block diagram, so block diagram shows clearly that this is my IR receiver. Okay. So this receiver is going to receive, and this input is going to go to AGC control unit. Okay. So this automatic gain control unit will be reducing the gain if there is a requirement or increasing the gain. So gain setting will be done by AGC part. Okay. Now it will pass it through the band pass filter to reduce any unnecessary noise signals. Then it will be passed to demodulator. This demodulator will send the signal to through this transistor, and the output will be appearing at this particular point. Okay, so this is my output signal. As you can see, this particular device is internally pulled up with 30 kilo ohm resistor, and this is my power supply input, and this is your ground pin. Okay, so similar to that, other block diagram is there, which is little bit detailed. So as you can see, this is my IR receiver input, and we have trans impedance amplifier, that is amplification. We have AGC control unit that I told you just now. We have band pass filter, which will limit the noise of like on outer of the like frequencies. So let us say it is working at 36 kilohertz. Then the center frequency of band pass filter will be 36 kilohertz with a little bit of band. Okay, which is close to 5% or something like that. And it has automatic threshold control. That threshold will be controlling it and sending it to the base of the transistor, and this base of the transistor will get activated, and automatically there will be burst output or the output format. There are different data formats that we'll be seeing. So this output will be going to the microcontroller IO pin. So we'll be connecting to a microcontroller IO where it will be going. Now if you see some of the application circuits. So application circuit, just now I'll be explaining it much better. Like we will have one series resistance which will be close to, let's say, uh, like 100 ohm. Okay, or if you want, you can increase to, let's say, 330 ohm. C1 capacitor will be there, which will be close to, let's say, 4.7 microfarad, and we have output voltage which is going to the microcontroller IO pin. Okay, and this is my ground pin. So this is the complete circuit that we'll be seeing. So what the circuit that we have already implemented in our PCBs for our client application, we'll show it to you. Then this is the application circuit again. If you want, you can take up a resistor also in the output line, which will be 1 kilo ohm. Okay, so this actually limits the current or limits the unnecessary, like a spike or something like that. There is one more thing that you can do is there will be a resistor that you can connect at the pull up at the output. Okay, so this can be around 20 kilo ohm. You can connect through your 5 volt supply. Okay, and this is your supply voltage, which will be, let's say, 5 volt. Now coming to the fact that we have some parts table, so we are concentrating on the parts of TSOP 134 series. Okay, so 134, 30, 33, 36, and 38. Okay, so these two parts we are going to implement in our circuit. And you can see we have mounting type, which is leaded. Its application is remote control, and it can be used for almost all the things like Cisco, Mitsubishi, NEC, and RC5, RC6. We have Panasonic, we have RCA. Okay, so there are so many, like applications are there. If you see maximum rating, so supply voltage can go up to 6 volt. The supply current can go up to 3 milliamperes. Okay, output voltage can be up to Vs plus zero point 0.3. So if you have a 5 volt, like system, then it will be going ahead. Output you will be getting up to around 5.3 volt maximum. Okay, so this is maximum. You don't have to worry about it. Will be giving you 5 volt only. Output current is going to be up to maximum 5 milliamps, and we have junction temperature that will be 100 degrees centigrade. The operating temperature that will be working is minus 25 to 85 degrees centigrade. So this is the operating temperature range, and this is the junction temperature range that is maximum allowed. But we should not talk about absolute maximum rating. We should be talking about electrical characteristics, which is allowed, which is the normal operating condition. So in normal operating condition, if you see, we have supply current of 0.35 milliamperes maximum, which is going to be 350 microampere just. Okay. So the supply current requirement is less than a milliamperes. So it has been really, enhanced a lot with the old devices compared to the old devices. We have supply voltage, which is going to be 2 volt to 5.5 volt. So this is very much suitable for your 3.3 volt application as well as 5 volt application. Okay. Now it has a transmission distance of around 39 meters. So up to 39 meter distance, you will be able to receive the signal. Okay. We have output low voltage, which will be maximum 100 millivolts. So it can be easily seen that their output is low. We have minimum irradiance, which is 0.05 milliwatt per meter square, and we have maximum irradiance, which is minimum 30 watt per meter square. So this is the beauty of this particular TSOP1 series IR receiver. We have directivity, which is going to be plus minus 45 degree. Okay, so plus minus 45 dB is there for the directivity, which is quite good. Now if you move forward, we have seen data format. So data format is basically nothing but what are the different formats that it can take up. So before that, we'll see this series is basically designated to what, or designed to what? Suppress spurious output pulses due to noise or disturbances signal. Okay, and those noise and disturbances signal are basically from where? It is from DC light, which is going to be tungsten bulbs and sunlights. These are continuous signal at any frequency. Let us say it is some TVs or like Wi-Fi or something like that. We have a strongly or weakly modulated patterns from fluorescent lamps with electronic blasts and all. We have 2.4 gigahertz and 5 gigahertz Wi-Fi. So all these disturbances will be mitigated or suppressed with this particular AGC control unit. Okay, so AGC is to ensure that no spurious pulses are present at the receiver's output. Okay. Now if you talk about the data formats, so data formats are quite good here. If you can see, we have RC5, RC6, we have NEC code, which are well recommended for remote control systems. We have any Sony code, we have RCA56 code. So whichever device if you want to use, you can utilize. So TSOP134 is most suitable like device for almost all kinds of application. So this is the best one. Now let us talk about the circuit implementation that we have understood. So circuit implementation, if you see, we are going ahead with TSOP 13436 as well as 13438. So this circuit device, it is a 3 pin. We have pin number 1 as output, 2 as ground, which is grounded, and 3 is VCC or VS. Okay, so this is the supply pin. So this supply pin is directly connected to a 5 volt supply. Okay, if you want, you can make it 3.3 volt as well. And there is a resistor that is used 100 ohm. So this resistor is basically used to suppress any, like a spike or something like that, you can increase it up to 330 ohms. Okay. Now this supply is actually backed up with 10 microfarad capacitors and zero point 0.1 microfarad filter capacitor, and the output is going to go to one of the microcontroller pin, which is RB0. Okay, so this is the IO pin that is going to your microcontroller. Now it is going through a 1 kilo ohm resistor. Okay, so that is the understanding. And if you want, you can keep a provision of 20 kilo ohm external pull up resistor. Okay, so this pull up resistor will make sure that output is like pulled up when it is high. So even if it is actually internally pulled up, if you want, for the safer side, you can keep it a pull up resistor outside as well. Okay. And there were older parts for this particular IRC receiver. So they were like TSOP130 series or TSOP138 or 136. Okay, so these were the parts that were being used earlier quite abundantly. Now if you are upgrading your system, or if you want to design a better system, you can go ahead with TSOP1 series, which is TSOP13436. So with this, hope you have understood almost all the requirements and designs and features about this particular IR receiver. And if you do have any questions or any comments about it, please do let us know in the comment box. Thank you so much.